So we've had a look at the fuel settings. Let's have a look at the combustion settings. So let's just play this a bit. So I turned up my fuel to 0.2, so it's what, four times higher than default, which is probably a quadratic thing, so it's probably exponentially a lot hotter. And you can see it's pretty white hot there and sort of explosive. I'm going to stop that. I'm going to stop. There we go. Let me just turn that to read so we don't get rid of it, just for the time being. So let's have a look at the settings here. So that's frame 12 for that. So the first one, the general ones, turn it on. We can play around with smoothness of the combustion. Increases value if you're getting jaggies. That's a sort of pixel squaring you can get on it. You know, there's sort of this sort of stuff which can be more pronounced in some things, and you can turn that up, but obviously be careful, because the more you smooth it, it will sort of lose details. It's sort of balancing out that. So yeah, so that was what that is. You have a read of that if you want to sort of get more into that. I'm not going to sort of get too bogged down in the combustion settings, because they get quite technical down here and stuff, but there's a couple of things that were quite good. So we can store a blue flame. Basically, you know, when you some sort of fire, like gas fires, they have that blue aspect to them at the sort of beginning of them, and then they go sort of orange later through the flame. We can store this information here. It's not on by default, and then you can access it later on in your shader. I may show that later on. It depends how much time I run out with. And then you can do the same for water vapor as well. Actually, when you heat up, you know, the air, water vapor is made in the surrounding area, and you can add that to it as well. It makes a more realistic sort of combustion sort of environment. So the next ones, these thermodynamic properties, these are quite important. This first one, expansion scale, you can use it to sort of control the sort of the violent explosive nature of your scale. So the larger the scale, the more violent your explosion is. Increase the expansion scale may cause very high velocities and hence slower simulations due to more substeps. Start from the default settings and gradually adjust expansion scale. Desired effect is achieved. So if you crank this number up, it's going to explode out a lot more. The one thing to be wary of is, as it sort of says there, if you're exploding out more, you're voxelizing this area a lot quicker. Your sims are going to get big and heavy and take a long time because you're exploding outwards. But that might be a factor of what you need to do. But just be wary of that. Because I think even now, let's go back to my cache. So when I cached that one to 52 frames, which I was playing you, it was already at a gig. So be careful with all these things. So we can, obviously you can also bring it down. So if I do that now, and turn my cache to play, or to write should I say, and hit play on the timeline. You can see it's not as explosively volatile as a big sort of boom cloud. It's not as expanding out much in that initial sort of. You can see it's sort of getting more of sort of less of a. So that can be quite a good one to play around with. Stop that. Go back to my combustion settings. So if I made it even smaller. And obviously we're only simming the first 10 frames. You're not really going to get a great sense of what's happening, but you can sort of see that it does generally change it. Actually not that much from 1 to 0.01. Let's try putting it up to 2. There we go, you can see it's gone boom. So you're getting this sort of almost massive explosion. But as I say, be careful with this because it will voxelize more of the area and you'll end up with bigger caches and longer sims. But you're getting this sort of big. There we go. Right, so that's a good one to play around with. Radiative heating, radiative cooling, they are basically, as the radiative heating, it's a multiplier for how quickly the heat will pass through the atmosphere. One of the really cool things about this new combustion in Maya is you can actually have ignition of one aero system by another. Well, actually, they have to be in the same aero here, but that one source air to another, just through the radiation of heat from one to the other one. If I just pause this, I'll find a video that shows it. I couldn't really find a video that shows it. There's a where was it? I've already lost that one. Let's have a longer version of it where you could see. Let's go back to the beginning of that. Here. That bit, this flame ignites this and this flame runs around it. Find a longer version of it. Anyway, so you can, it actually doesn't heat up the air in between, but it can make other objects warm up. I would do a setup for it, but it's going to take too long. So basically I could have another air over here that doesn't have any temperature, which is below the ignition of its temperature. And then you would have this one, and it would basically, as this one gets hotter and hotter and hotter, it will actually ignite that one. It's pretty cool. I wonder if I've got actually, let me pause it. I found a test I did, it took me a while. So this is burning. This has got fuel and it's an aero attached to it, but it's got fuel on it, but it's not got any temperature to it. And then this at the end is another one that's got fuel on it but hasn't got any temperature to it. This is the only thing that's got high temperature to burn. So as it goes closer, you can see it ignites that and then it jumps to another preview. But you can see it's pretty, it goes and then whips around. So that's pretty cool. I mean, you never used to be able to do stuff like that. And you can sort of multiply that with this radiative heating thing. It will make it a bit quicker to ignite stuff. Where are we? And the same with cooling. Cooling is quite good. It will make the temperature in your simulation cool a lot quicker. Can keep sort of like, if you want to shorten flames but you're finding it difficult, you can crank this up and it will keep your flames a bit shorter. The frame propagation speed. I'll have a look at this. Scales the speed in which the frames propagate. In general, the flame propagation speed is a particular point in space. It's determined by a combination of fuel, blah 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 blah. And for the flame propagation speed is based on actual real world and can be unified. I've not actually used this much. I think it's probably quite a subtle change because obviously the combustion, everything sort of ignites very quickly anyway. Oxygen diffusion. Controls the amount of oxygen diffusion. Oxygen diffusion, important model phenomena. Cluster produce. I'm trying to remember what this does. Oh yeah, so this is when you mix this with I think it's soot formation. Or I think it's this oxidized soot one. If you have that turned on, oxidized soot, and you turn on oxygen diffusion a bit higher, it can basically give you more like candle flames. You get less smoke off them. So sort of playing around with that can be quite good. And the same here. This is all this sort of stuff is basically playing around with how much smoke and how it will oxidize. I won't go through all of them because I've already sort of waffled on, and me reading out the info off it isn't. You can do that yourself. So, but the big ones are in here. There's radiative heating and cooling. Cooling can make you clamp the flame a bit down. Heating can make it propagate into other sources quicker. This blue flame is quite good. I could show you how to do that. I probably will do. And yeah, and that expansion scale for an explosion. So they're the sort of big settings there. Right.